So in this video we're going to have a look at the 2016 question 12 part D. Now in this year the particle physics question, the option question, was only actually worth half a question, which is disappointing because in a lot of years it's worth a full question. So if you bank on it for a full question, you're not guaranteed you're going to get a full question with it, but you should at least always get a half question. So the question is, the pair annihilation of an electron and a positron has been investigated for many years at CERN in Switzerland. 2 gamma ray photons are produced during this annihilation. What is a positron? So first question, what is a positron? Very simply, it is a positively charged electron, and that's all you have to write. You could write the electron's antimatter equivalent or an anti-electron. And just writing either one of those will give you 3 marks. That's the first bit done. Why are photons always produced in pairs during pair annihilation? So this is something that I mentioned in the videos. And again, it's a really short answer. Very simply, to conserve momentum. So if there's no, say if this is our, what are we talking about, our pair annihilation. If there is a electron and an anti-electron coming together in this direction, at the moment the momentum in the vertical direction is 0. So you can't just produce one photon going in this direction because we no longer have a 0 momentum in the vertical direction. So what you have to have is you have to have another photon going in the opposite direction, so the momentum of this photon cancels the momentum of this photon, so the overall momentum stays as 0. But all you need to write is to conserve momentum, and that will get you 3 marks. Write an equation for this annihilation. So at the moment, all I'd kind of hope you'd write is electron plus, remember the symbol for an anti-electron or an antiparticle is just the same with a bar over it, gives us 2 photons. Or you could write E plus E bar gives us 2 HF. So either one of those. Now there is probably a slightly better way. We will talk about it a little bit more in the next video, but if you remember when we did beta decay, the way we wrote an electron in the equations was E0 minus 1. Now we either wrote it like that or we wrote it like this. So if you look back at beta decay, you'll see where that comes from. So if that's the symbol for an electron, an anti-electron or a positron would be plus 1, 0. And again, we'll talk a little bit about this in the next video. Goes to 2HF. So any one of those for the moment is acceptable. In the mark scheme, you'll see the last one. So the last one's probably the best. Now that was worth 8 marks in the mark scheme. I don't know how they've broken up the 8 marks. Next question. Calculate the frequency of the gamma radiation produced in this annihilation. So we have an electron and an anti-electron gives us 2HF. So we're looking for F. We're looking for the frequency of those photons. So we need to get the amount of energy that is converted. So we use E equals mc squared. And just writing down that gets you 3 marks. So mass of an electron is on page 46 of your tables. 9.109 times 10 to the power of minus 31. All multiplied by the speed of light squared. Now we have 2 of them, so we can multiply that by 2. Gives us an answer of 1.639 times 10 to the minus 13 joules. So that 1.639 times 10 to the minus 13 joules, 9 times 10 to the minus 13 joules is equal to 2HF. We're looking for F, so F will be 1.639 times 10 to the minus 13 divided by 2H. And H, remember, is Planck's constant, and that's on page 47 of your tables. So when you type that in, and you can go and do that now yourself if you want, you should get an answer of 1.2 times 10 to the 20 hertz. That's the frequency of the photons. For that question, you got 3 marks for writing E equals mc squared. You got 3 marks for writing E equals HF. And then you got another, I think, 3 marks for your final answer. Sorry, you should only get 2 marks for E equals mc squared. That should just be 2. Last part of the question then was compare the energy produced in the, the pair annihilation of a proton and an antiproton is now being investigated at CERN. Compare the energy produced in these two annihilations. Explain your answer. So basically they're just asking, how would you compare the energy produced in a proton and an antiproton to an electron and a positron? Well, very simple answer. Protons have a much larger mass. They're much bigger, nearly 2,000 times bigger than electrons. And because they have a much larger mass, the energy produced would be much greater. Why would it be much greater? Because E equals mc squared, and obviously the bigger the mass, the bigger the energy. So 3 marks for saying protons have a much larger mass, and 3 marks for saying so you'd have much greater energy. And that's the question.